my dear kids, a very warm good morning to all of you. How are you all? How's your new year going? How's your new year going? Actually, it's 2nd of January, right? So, how did you guys celebrated your new year? How are you all? Hello everyone. Good morning. So, New Year कैसा गया? What did you guys do? How did you guys celebrate it? I'm sure it went great. Yes, you guys had lots of fun. And are you excited for today's lecture? Today we will be discussing carbon and its compounds. It's one of the most requested lecture by all of you, my dear students. You had lots of doubt in this chapter. So we'll try to cover each and every doubt and make this chapter your best scoring chapter. So are you ready, guys? Are you ready? Okay, so we started, the chapter name is carbon and its compounds, right? The chapter name is carbon and its compound. What makes this carbon so special that we have an entire chapter dedicated to this? There is sulfur, there is nitrogen, there is oxygen also. Why not we have sulfur and its compounds, oxygen and its compounds, nitrogen and its compounds? Why we have one dedicated chapter in chemistry in your science, 10th class science book about carbon and the compounds it form? Why? Hello Goku. Anyone? So see, carbon has such a vast number of compounds because it has certain properties. It has certain properties that are unique to it, and due to these properties it forms millions of compounds. Okay, because it is very versatile in nature. Correct, Goku, that's one of the reason. But the main properties because of which it exists in like millions of compound form may it exists, right? There are millions of compounds of carbon. Okay, so let's find all these answers, okay, one by one. Let's decode this chapter. Catenation, correct. So catenation is 1. Okay, so firstly, what is the atomic number of carbon? 6, right? That means it has 6 electrons and 6 protons. Is it clear? The atomic number of carbon is 6. That means it has 6 protons and 6 electrons. And what about the number of neutrons? Yes, Goku, tetravalency is also there. So tell me the number of neutrons in carbon. What are the number of neutrons in carbon? Yes, Goku, tetravalency, catenation, yes, they are one of the major reason for carbon to exist as so many compounds, and millions of compounds of carbon exist. Yes, see, carbon, atomic number of carbon is 6. Yes. Say hi, Rohit says 6. Yes, the number of neutrons in carbon is also 6. So it has number of protons, neutrons and electrons. All are 6 each. 6, 6 and 6. Correct. Okay. See, it's such a tiny compound, right? It's such a tiny compound. And one more shocking thing you would be very shocked to know. In our earth crust and in our atmosphere, in our earth crust, how much carbon is there? Any guesses? How much carbon is present in our earth crust? Yeah, guess. Guess, my dear kids, how much carbon is present in our earth crust? You will be shocked. In our earth crust, it is about 0.02%. So say hi, Rohit. Yeah, in crust it's 0.02%, and in our earth atmosphere, in the atmosphere as carbon dioxide, it is present as 0.03%. Shocked, right? It is so small, right? 0.02%. It's not even 1%. 0.03% in our earth atmosphere. In the form of carbonates, hydrogen carbonates, yes. That is in our earth crust. It is present as carbonates and hydrogen carbonates. Okay, let's test your knowledge. Okay, just tell me, what is the difference between carbon compounds and organic compounds? What is the difference between carbon compounds and organic compounds? Okay. Rohit says it's very large amount. It's not large amount. 0.02%, 0.03%. That is very small amount. Yes, so tell me, what is the difference between carbon compounds and organic compounds? Organic compounds have hydrogen atoms bonded to carbon chains. Okay, Rohit, so carbon compounds have the same, right? They also have carbon bonded to hydrogen atoms, right? Hydrogen bonded to carbon atoms. That's also there in carbon compounds. What is that one thing that differentiates between carbon compounds and organic compounds? I'm waiting for your answers, my dear kids. Okay, the difference is, yes, both carbon compounds and organic compounds have carbon and hydrogen. It also has carbon, oxygen, carbon, nitrogen, carbon, sulfur, other atoms also. Okay. Both have, again Rohit, your carbon compounds and your organic compounds differ by only one thing. Yes, both have covalent bonds. You know, carbon compounds also have covalent bonds. Organic compound also have covalent bonds. You know, carbon only forms covalent bonds. It majorly forms covalent bonds only, okay? It can't form ionic bond, can't form a cation, can't form an anion, right? So, Rohit, the major difference is your organic compounds are produced from living. They have a living source. Okay? They are generated or produced from a living source. Okay, but your carbon compounds, they mostly are synthesized, they are mostly obtained from your non-living sources, rocks, minerals, right? Carbonates, hydrogen carbonates. Yes, oxides of carbon, these all are carbon compounds, but they are not organic because they are not obtained from a living source. Clear? I hope it is clear to all the source difference. Okay, your organic compounds are obtained from living sources, while your carbon compounds, they are not obtained from living sources, right? They are present in our earth crust as carbonates, hydrogen carbonates, right? Oxides of carbon, sulfides of carbon, oxides of carbon. That vital force theory was rejected, right? Yes, correct, Rohit. That vital theory was rejected because one scientist synthesized an organic compound from a non-living source. That will be discussed later on. But yes, that was an old theory. But for now, you need to remember your organic compounds are synthesized from living sources, and your carbon compounds, they do not have any origin from living sources. That was rejected later on. Your book was published before that. Okay, just kidding. Okay, so your carbon, it has a atomic number of 6, which means its electronic configuration is 2, 4, right? Its electronic configuration is 2, 4. That means in its outermost shell, it has 4 electrons, right? In its outermost shell, it has 4 electrons. So how many more electrons it needs to complete its octet? Octet means having 8 electrons in its outermost shell. Octet means having 8 electrons in its outermost shell. So how many electrons it needs? It needs only 4 electrons. It needs only 4 electrons to complete its octet and get a stable noble gas configuration. Okay, that's one way. Either it can complete its octet or it can complete its duplet. It can remove all the 4 electrons and have only 2 electrons. This is called duplet, having 2 electrons in their outermost shell. This is called duplet. Okay, so there are 2 ways. Either it can accept 4 electrons and complete its octet, or it can lose 4 electrons and complete its duplet. But for hydrogen, both of these ways are not possible. Why is that not possible? Why is that not possible? Okay, so when hydrogen tries to gain 4 electrons, so when you are gaining electron, when any atom is gaining electron, lots of energy is required. Lots of energy is required to add electrons, to accept electrons. Lots of energy is required. So that much energy is not available when you're trying to convert, when you're trying to add 4 electrons to this tiny atom carbon. 6 protons can't hold to 10 electrons. That is one reason. Same as the energy one, right? There will be so much repulsion between those electrons that the protons can't hold on to those 10 additional, those 4 additional electrons. Okay? Isn't energetically feasible. Yes, correct, Rohit. So both processes are not energetically feasible. Okay, so if you try to remove 4 electrons, again you need lots of energy. Okay, so for us that much energy is not very feasible to provide, the process won't be spontaneous. Okay, you need lots of energy to give to remove the 4 electrons. So neither it can donate 4 electrons, lose 4 electrons, nor it can accept 4 electrons. Okay, so what does it do? It can share. It can share its 4 electrons, okay, and complete its octet. It can share these 4 electrons and complete its octet. Clear? So it does not lose 4 electrons, it does not gain 4 electrons. What it does, it share 4 electrons. How does sharing happens? कोई और atom is there, उसके पास भी deficiency है, उसके पास भी electrons नहीं है, ना वो lose कर सकता ना वो gain कर सकता. So what they will do? They will share. How will they share? For example, you have A and B. You have A and B. A have roti, B have dal, right? ना तो A का रोटी से पेट भरेगा, ना B का दाल से पेट भरेगा. So what they'll do? They'll share. I'll give some roti to you, I'll give some of my roti to you, and B said I'll give some of my dal to you, and thus both can fulfill their requirement. Similar to that, atoms in chemistry, they form this bond that's called covalent bond, which is formed by sharing of electrons. They both share electrons. Chemistry में food तो है नहीं, we have electrons, right? So sharing of electrons and the bond formed by the sharing of these electrons is called a covalent bond. So your carbon forms covalent bond, correct? How is that bond formed? That bond is formed by sharing of electrons. What is that bond we call, which is formed by transfer of electrons? What is that bond called which is formed by transfer of electrons? Okay, so carbon, it cannot lose or gain 4 electrons. It has a valency of 4. Valency means the combining capacity of atoms. So carbon can combine with 4 other atoms. Carbon can combine with 4 other atoms. Okay. Thus, your carbon forms covalent bond. Why? Because it cannot lose 4 electrons, cannot gain 4 electrons. That's why it forms covalent bond with other atoms. It shares its electrons and complete its octet. Clear till now? Now, your covalent bond is majorly of 3 types. Your covalent bond is majorly of 3 types. Okay? When one electron sharing is happening, when only one electron is getting shared. So for example, carbon, you have, let's say, hydrogen, so here only one electron sharing is happening between carbon and hydrogen. Only one electron sharing is happening. Hello, legend. Yes, I know you kids had lots of doubt in this chapter. Okay, so here only one electron is getting shared. Only one electron sharing is happening between carbon and hydrogen. So this is your single covalent bond. Single covalent bond. We were discussing covalent bonding. Covalent bonding is formed by sharing of electrons. When two atoms, hello legend, so when two atoms are sharing their electrons, the kind of bond formed is covalent bond. Now covalent bond is of 3 types. We have when both the atoms are sharing only one electrons, it's called a single covalent bond. When the number of electrons that are getting shared are 2, for example, your oxygen. Oxygen has 6 valence electrons in its outermost shell. No, legend, you are totally on time and I was waiting for you all. Yes, correct. So oxygen has 6 electrons in its outermost shell. So 1, 2, 3, 4, 5 and 6. Similar, we have one more oxygen. It also has 6 electrons. 1, 2, 3, 4, 5, 6. So oxygen needs 2 electrons to complete its octet. It already has 6 electrons, right? It only needs 2 electrons to complete its octet. So what it will do? It will make a bond. It will share these 2 electrons, with the other oxygen. It will share these 2 electrons with the other oxygen and form a covalent bond. Okay? So now see, this oxygen, the oxygen on the left hand side, it has complete octet 1, 2, 3, 4, 5, 6, 7, 8. Similarly, oxygen on your right hand side also has a complete octet 1, 2, 3, 4, 5, 6, 7, 8. Okay, both oxygens have complete octet. Both are stable. Okay, so here the bond formed is a double covalent bond. By sharing 2 electrons. How many electrons are getting shared? By sharing 2 electrons. No, RCR gamer, I'm not ignoring you. Covalent bond are of 3 types. Yes, legend. So RCR gamer will try to complete all this chapter and 15 most expected question from this chapter, that also. So be prepared. Yes, correct. Now, triple bond. When there are 3 electrons getting shared. When 3 electrons are getting shared between 2 atoms, the type of bond formed is triple covalent bond. Okay? So for example, you have nitrogen. 1, 2, 3, 4, 5. Nitrogen has 5 electrons in its outermost shell. Electronic configuration is 2, 5. Okay? Similarly, this nitrogen also has 5 electrons. So it needs 3 electrons. Nitrogen needs 3 electrons to complete its octet. So kahan se lega 3 electrons? It will share these 3 electrons with the other nitrogen. Now it has a complete octet 1, 2, 3, 4, 5, 6, 7, 8. Clear? Similarly, the other nitrogen also has a complete octet. Clear? The bond formed is a triple covalent bond. It is a triple covalent bond. Okay, Lokesh, I will remember your name. Now, what are the properties of this covalent bond? See, covalent bond is formed by sharing of electrons between 2 atoms, right? Now the bond, ये वाला bond जिन भी atoms में होगा, all the atoms having, all the compounds or molecules having this covalent bond are called covalent compounds. There are some properties of this covalent bond, okay? These properties are also showcased in the compounds, in the covalent compounds, okay? And what are those properties? So firstly, your covalent bond is very weak, is a weak bond, okay? Covalent bond is a weak bond. So your covalent compounds have low melting and boiling points. So hi Lokesh, my name is Ekta. As you have seen it in the thumbnail also, I'm Ekta Ma'am. I will be taking your chemistry classes. Okay, so your covalent bond is extremely weak. It's a weak bond, right? And as it is a weak bond, so only little force is required to break this bond, right? So it has a low melting and boiling point. किसी भी compound में, if any compound has a covalent bond, it will have low melting and boiling point. Clear? That's one thing. Second thing, when we were making this covalent bond, here we were making the covalent bond, here we were making the covalent bond. Was there any ions present? Was there any ions present? कहीं पे भी there was a transfer of electrons, cation was getting formed, gain of electrons, anion was getting formed? No. We were only sharing the electrons. We were only sharing the electrons. Hello Bandhan, good morning. Yes, Lokesh. There were no ions, right? There were no ions. And to conduct electricity, To conduct electricity, you need ions. To conduct electricity, you need ions, cations, anions, okay? So here, the bond was formed by sharing of electrons. So there were no ions involved. So will they conduct electricity? No, they will not conduct electricity. Your covalent compounds do not conduct electricity. But in carbon, there is one exception. In carbon, there is one exception, and that is your graphite. Graphite. Graphite is a good conductor of electricity. Graphite is a good conductor of electricity. It is a covalent compound. It is a covalent compound, yet it is a good conductor of electricity. Okay? Yes, Gia, you can score 90 plus in boards easily. For that, you need discipline, you need revision, you need to solve questions regularly, and you need a conceptual revision every day. You can easily score 90 plus in your board exams. So, Lokesh, all these chapters carry equal weightage. Actually, there are only 4 chapters, right? And around 7 marks each you are getting. There is no such thing as this is a high weightage chapter or low weightage chapter. The question may vary. Some chapters you will get the MCQ questions, and from the some chapters you get the 3 marker and 5 marker question. Okay, so that only in that sense they varies, but most majorly they try to do it 7 mark each chapter. So Gia, try to be disciplined, and again one more thing, do daily revision plus question solving, as many questions as you can solve, okay? And do abhi to it's not much time left. February may you have exam, right? So till then try to do as many full seated mocks, you know, for an exam you sit down for the whole 3 hours and do your exam, okay? In a total exam way mein, okay? I would recommend that. Okay, so covalent compounds have low melting and boiling points. Why? Because covalent bond is weak, because it is formed by sharing. There is a sharing. Agar ek ne electron nikal liye, to obviously the bond is broken, right? The bond is very weak. That's why they have low melting and boiling point. They are good, not good conductor of electricity, poor conductor of electricity. Why? Because there is no ions. The bond is formed by sharing. Only sharing is there. There are no ions, no electron transfer happening. Okay? So ions and electrons, they are your charge carrier. Due to them, the electricity carrying happen. Okay? अगर है ही नहीं तो फिर कहाँ से होगा? Okay? So they are poor conductor of electricity. Next one, they are insoluble in water. They are insoluble in water. Again, water is a polar solvent. Polar means your water has H2O, right? Hydrogen and oxygen it has, okay? So there is some sort of electronegativity difference. Hydrogen is less electronegative, oxygen is more electronegative. Due to that, your hydrogen has delta positive charge and oxygen has delta negative charge. These are called your poles. These are called poles, dipoles or poles, whatever you call. And due to these poles, water is a polar compound. Okay? Ab iske paas poles hain, it has poles, right? Positive and negative. So it will only be able to solubilize those compounds that have the same thing, like dissolves like, right? Really, sorry. No worries, Lokesh. Do not be scared of chemistry. I'll help you all. Don't worry. It's too hard for me. It's okay, Lokesh. I am here. If you have any doubt, just tell me. I'll answer each and every doubt of yours. Van der Waals force. So Crompton animator asks what is van der Waals force. First of all, that's not the correct spelling. The van der Waals force is van der. And secondly, it is a weak force that exists between 2 molecules. When you have 2 molecules, let's say you have one hydrogen molecule and other hydrogen molecule, the type of force that exists between these two molecules, that's your van der Waals force. That's your van der Waals force. It's a very weak force. It is much weaker than covalent force, because covalent bond, they are still closer by. For your van der Waals forces, if one molecule is here and the other molecule is lying there will be some sort of van der Waals force existing between them. Okay, so it's a very, very weak force in nature. That's the weakest of all forces. Yes, Lokesh. So reactions will be a little difficult, but you need to see what is there. We will discuss it later on. We have reactions here also, right? Okay, so it is insoluble in water because it does not have any poles. For solubility, remember only one thing: like dissolves like. If a polar solvent is there, it will only dissolve polar compounds. Okay, your covalent compounds are non-polar. One more thing is there, it's not there in your syllabus, but we have polar covalent compounds also. That means there are some compounds which have covalent bond, but they have poles, like these, because there is electronegativity difference between the two atoms combining. Okay, for example, you have HCl. It is a covalent compound, yet it has poles. Hydrogen is slightly positive charge and chlorine has slight negative charge because of the electronegativity difference. So in covalent compounds also there are two types: polar covalent compounds and non-polar covalent compounds. Okay, where there is more electronegativity difference, वहाँ पे मिलेंगे polar covalent compounds, and when there is same electronegativity between the two compounds, no electronegativity difference, you call them non-polar covalent compound. So legend, it is not an electrostatic interaction. It is not, there is nothing electrostatic in between your van der Waals. It's just a force existing between two elements, force of attraction kind of, not electrostatic exactly. You're welcome, Crompton. Yes, Gia, chemistry is difficult, but do not worry. Yes, correct. Yes, Lokesh, it will be easy to understand if you just follow along. Okay, the last one is they are soluble in organic solvents. Again, what are your organic solvents? The organic solvents are those solvents which do not have pole. They are non-polar in nature, like benzene, chloroform. They have no poles, no positive negative charge there. Okay, so your carbon compounds, covalent compounds, they are non-polar. Majorly the types that we are talking here are non-polar. So for your non-polar covalent compounds, they are soluble in organic solvents. Okay, the next one is allotropes. Okay, we forgot these, the reason for the existence of large number of carbon compounds. First one is catenation. What is catenation? Catenation means ability to form long chain of compound bonds with itself. So carbon has the ability to form long chain of bonds with itself. Carbon can form long chain of bonds with carbon itself. Okay, now I don't say ki other atoms don't. Other atoms do have the same ability. They do have. For example, sulfur can also form long chain of sulfur compounds up to S8. Okay, but the stability of those compounds, the stability is not great. They are not stable. But your carbon compounds, if you form long chain of carbon compounds, they are very stable. And that is one of the reason for existence of large number of carbon compounds. Class 10 syllabus chemistry and all the other subjects are similar, so I can start class 11th course PCM because I want to do JEE. That is very nice, Crompton. Yes, if you have completed everything, just do revision every day and do mocks whenever you have time, and yeah, you can start because the basic part is from here only. You're best from now onwards because 11th is tough if your 10th concepts will be weak. Yes, legend. So Lokesh, don't worry, the lessons you have in your science, they are very concept based. They are logical. Actually, you have a logical explanation for everything that's written. Okay, so need not worry. Try to focus on the reasoning and your answer writing. Focus on that also, so that you can complete your answers in time in your exam. Okay. Okay. The second reason is tetravalency. Carbon has a valency of 4, so it can form bonds up to 4 atoms. It can form bonds up to 4 atoms, right? There are 4 possibility, 4 bonds it can form. So due to that reason also, it can form large number of carbon compounds. Okay? So एक time पे एक atom can form bonds with 4 atoms. Then you have other carbon that can also form bonds with other 4 atoms, right? So you can form long chains and you can form multiple compounds, right? Because एक atom 4 atom के साथ bond कर सकता है. Hi Ishant, are you new here? Okay, hello Ishant. Now let's discuss the allotropes of carbon. What are allotropes? I got 96% in my board exams. Hi Ishant, tetracovalency. Tabish replies tetracovalency. So allotropes of carbon. What are allotropes of carbon? So see, allotropes mean they are still carbon compounds. They all have carbon. If they have carbon, so they will show the same chemical properties as shown by carbon, right? What is the difference? The difference is in the physical structure. The physical structure is different for these compounds of carbon. They are carbon compounds. They show similar chemical properties as carbon, but they have different physical structure. Yes, same chemical element in the same physical state. Actually, your allotropes. Yeah, so your allotropes are they are made up of same chemical element showing same chemical properties but different physical arrangement. Okay. And legend, you can score 95 plus very easily. Yes, you need to put the effort. You need to study. You need to be disciplined. You need to avoid the distractions. Okay? Because only majorly like 1.5, mushkil se 1.5 month is left. So in that you need to cover the 5-6 subjects that you are studying. Okay? And I believe you can score that. Okay, so these are your allotropes. There are 3 allotropes of carbon that we study in this chapter. First one is diamond. Diamond, shiny diamond. Okay, so your diamond has carbon. Okay, first of all, the structure. Let me just. The structure of diamond. It has this 3D network of carbon. We have carbon. It has this 3D network of carbon. So in diamond actually you have 3D network of carbon where every carbon atom is bonded to other 4 carbon atoms. Okay. Every carbon atom is bonded to other 4 carbon atoms. So you have a carbon that is bonded to 4 other carbons. This carbon, this carbon, this carbon. And now this carbon is like this. This is bonded to other 4 carbons. There is other carbon here. I hope I'm able to make you visualize it, but it's in a 3D arrangement. It's not a 2D thing. So this carbon, this one carbon we have, this one. this one carbon we have, this one, so it is in 3D, it's outside, it's like this carbon skeleton and this one is pointing outside. Good afternoon, Ashish. Okay, how can I learn chemistry moment also? Diamond is very shiny. Lokesh, diamond is very shiny. So once light gets inside the diamond, it gets trapped there forever. So a diamond will be forever shiny. Which one is most prominent regarding the boards? Tabish, as in chapter you are asking, or any like topics in this chapter are you asking? Good afternoon, Ashish. Architecture gives dia a shape, and when light passes from it, looks shiny. Yes, that's why I'm telling they are very shiny, because yes, they do give it a shape, yes, but it can trap your heat and light. That's a good conductor of heat. Please, ethanol structure. Yes, we will discuss ethanol. Don't worry, graphite can conduct electricity, but diamond cannot. Yes, Gia, I'm coming on to that reasoning just now. Hi, ABCDF. Raw diamond is not shiny. Yes, obviously. It is shiny, not that shiny as you are talking about. Obviously, polishing requires. They have dirt covered and everything, you know. Obviously, they won't be shiny. Allotropes may say the major thing that they ask is this: why graphite conducts electricity and diamond does not? When it comes in shape, but when workers extract from the ground, it's not shiny. It's not shiny. Free mobile electrons, they are not. Yes. Okay, ABCDF. You all have seen raw diamonds, I believe. Okay. So what happens is, your diamond is one of the hardest substances on Earth. On this planet, one of the hardest substances is diamond. So you can cut anything with a diamond, okay? You can cut anything with a diamond. And they are very bad conductor of electricity. Why? Because your carbon is bonded to, each carbon in diamond is bonded to 4 other carbons. Each carbon in diamond is bonded to 4 other carbons. There is no free electrons. There is no free electrons available. And for conduction of electricity, you need ions or electrons. दो ही चीजें चाहिए होती है for conducting electricity, ions or electrons, but neither of those are available here. So that's why your diamond cannot conduct electricity. Clear? Yes. Yes, Lokesh, your future is more shiny than diamond. So Tabish, I hope I answered your doubt. Harav, bonding. Hello, physics. No free electrons, right? Graphite conduct electricity. So Ashish, I believe, yeah. So graphite is able to conduct electricity because of its structure. Okay, let me draw the structure. You have these hexagonal arrays we have. These hexagonal arrays have, and they are layered on top of each other. They are layered on top of each other. In graphite, each carbon, first of all, we have these hexagonal arrays. Okay, it's a 2D structure. This is a 3D structure, and graphite has a 2D structure. Okay. Ashish, because it is one of the hardest material, na? It's expensive because of its rarity, because of the amount of kitne mines bache hain pure world mein, and plus the sellers and the person who can extract it. Bahut limited companies have the authority to do that. Okay, so due to these reasons, it is expensive, and because we have no other option that is as hard as diamond to cut on the surfaces. For example, kuch ek do machineries hote hain, even to cut diamonds you need diamonds. To cut diamonds, you need diamonds. Okay. So, where were we? It has a 2D structure, 2D hexagonal array structure. Okay. In this structure, each carbon atom is bonded to 3 other carbons. Each carbon atom is bonded to 3 other carbons. One electron is free. It has one free electron. And due to this one free electron, it can conduct electricity. Again, condition क्या है कि it should have either ions or have electrons, and यहाँ पे it has one extra electron, one electron left that is not bonded, one free electrons, and due to this one free electron, your graphite can conduct electricity. They are very soft. Why are they soft? Graphite conduct electricity. Ashish, I hope I answered your question. So graphite can conduct electricity because it has a hexagonal 2D array structure in which each carbon is bonded to 3 other carbon atoms. One free electron is there. Due to that one mobile electron, it can conduct electricity. Clear? Why is it soft? It is soft because these 2 layers, see, in here we have covalent bonds. These carbon atoms have covalent bonds. Here also we have covalent bonds, but they are weaker covalent bonds, okay? Because they are stacked on top of each other. So you can, if you apply enough force, you can slide it. You can slide it. That's why they are very soft. In between they have is upar wala layer, this above layer, and the below layer, they have covalent bonds, right? That is strong. In between them, there is strong bond. Okay, खुद exist कर रहा है. But what happens if you try to slide it? If you apply enough force, बहुत easy है because there is not strong bond in between these layers. These layers have very weak covalent bond. Okay, and due to that, it slides straight on top of it. Okay, that's why they are very soft. Hello physics. Hello miss. Myself. Okay, Kanak. I'm good. How are you? Thank you, ABCDF. I will gift. Okay, Lokesh, that is too much. Okay, I can gift myself. But thank you for the thought. And yeah, sure. One day maybe you can give me. You will have your own factory of diamonds. So expensive. Okay. Not expensive than me. Yes, Kanak. Diamond is not expensive than you, my dear kids. It is not. Diamond have time. Yeah, there are different cuts of diamond, na? So Tabish, covalent compounds have low melting and boiling points because covalent bond is weak in nature. Covalent bond is very weak. So to break that bond, you need only little energy. Little energy is required to break that covalent bond. That's why they have very low melting and boiling point. Okay? Melting boiling point का मतलब क्या होता है? One state से दूसरी state में solid to liquid, liquid to gas, right? Melting means solid to liquid, boiling means liquid to gas. Basically, you're trying to break the bond, and if the bond is weak, so only little energy is required. So that means low melting and boiling point. Clear? I have, yes, physics. You can, yes, Kanak, you can ask the doubt about acid, bases, and salt. Yes, I think Lokesh, you should do your research on this. How was the first diamond cut? Note, please ask question from this chapter. No, it's okay. If you want to ask, it's okay. I can answer your doubts. No worries, legend. I have a doubt, why does carbon form covalent bonds instead of ionic bonds? So, Jia, I answered it right at the beginning. For gaining 4 electrons, for making ionic bonds, 2 possibilities are there. Either it can form a cation, it can form an anion. For forming an cation, carbon will need to lose 4 electrons. If you can just visualize the process, losing 4 electrons is highly energetic process. First of all, you need high energy, okay? It's not energetically feasible. That's why we cannot lose 4 electrons of carbon, okay? Carbon के 4 electrons lose नहीं होने वाले, okay? Hi Sparsh. Yes, physics, you can ask. Okay, so first one is cation, right? So cation, it can't form cation. Why? Because it can't lose 4 electrons. That's not energetically favorable. The second thing is it can gain 4 electrons, right? In that case, it will form an anion, right? If carbon were to gain 4 electrons, so already it has 6 protons balancing 6 electrons. If additional 4 electrons are added, then you have 6 protons trying to balance 10 electrons. That is very difficult, right? And in addition to that, these 10 electrons will be repelling each other also because carbon is this small, very small. Only 2 shells are there, K shell and L shell. Okay, so due to these, it cannot form ionic compound. As it cannot form cation, it cannot lose 4 electrons. Why it cannot lose 4 electrons? Because that is not energetically favorable for your carbon. It cannot form anion. Why it cannot form anion? Because 10 electrons will be too hard to balance by 6 protons, and there will be an additional repulsion between the 10 electrons also. Thus, it cannot form ionic compounds. It cannot form ionic compounds. How are your ionic compounds formed? Ionic compounds are formed by transfer of electrons. So, it cannot transfer the electrons. So, what it will do? It will share the electrons, and thus it will form covalent bond. I hope your doubt is clear. Jia, hi, Sparsh, hence proved. Thank you, Lokesh. Hi, okay. Sparsh. Diamonds weren't cut, they were just polished to gain a shape. Thermite reaction. So, Ashish, the thermite reaction is a reaction between iron oxide and aluminum. Iron oxide and aluminum. And we get aluminum oxide in this page. Okay, let me just finish this one, then I'll tell you the thermite reaction. The graphite, why are they soft and they are good conductor of electricity? I hope you all know the reason now. Then you have fullerenes. Fullerenes have C60. Fullerenes have C60, 60 carbons, and they have this shape of a dome that's in Europe, or I think America. In America, there's a building that was designed by a scientist, by an architect whose name was Buckminster Fullerenes. So on that name, on that shape name, this shape name was given, okay, because it looks similar to that one, okay. And the purpose, it's very neither soft nor too hard. It's a hollow sphere. It's a hollow sphere, okay. Now let me answer your doubts. One car. Okay, Ashish, so thermite reaction is when iron oxide reacts with aluminum and we get aluminum oxide plus iron. This is in molten state, liquid. Plus lots of energy is released. Plus lots of energy is released. Okay, now you see this is your thermite reaction, okay. Aluminum is more reactive than iron. In the reactivity series, if you know, aluminum is more reactive than iron, and because of that, it can displace iron from its compound. It can displace iron from its compound, and we get molten iron. We get molten iron. Molten matlab liquid iron, okay? And this liquid iron is used to fill the tracks, fill the railway tracks. Jahan pe bhi we need the bonding, jahan pe bhi track is broken, you do this reaction and lots of molten iron is released, and that iron is used to connect those broken tracks. Yes, carbon is tetravalent bond. Syllabus khatam kar diya. Yes, ma'am, I'm. It is of great thing. Thermal reaction is highly metal. Yes, correct, legend. Okay, guys. Okay, so that was your thermite reaction. Ashish, I hope your doubt is cleared. Okay, moving on. What are hydrocarbons? Hydrocarbons. Hydrogen plus carbon. That means compounds containing carbon and hydrogen. Compounds containing carbon and hydrogen. Okay, they are your hydrocarbons. Now, what are the different types of hydrocarbons? What are the different type of hydrocarbons? We have alkanes. What are alkanes? Alkanes means saturated hydrocarbons. So we have two type of hydrocarbons, saturated and unsaturated. Difference kya hai? In between your saturated hydrocarbon and unsaturated hydrocarbon, what is the difference? So your saturated hydrocarbons have single bonds, only single bonds. There is no double bond. There is no double bond in that particular compound. If your hydrocarbon. Firstly, hydrocarbon means hydrogen and carbon is there, okay? Second, there is only single bond in between all the carbon and hydrogens, carbon and carbons, okay? That is your saturated hydrocarbon. So basically the distinction, पहली बात, if you say कि ma'am carbon hydrogen के बीच में double bond, so that won't be possible because hydrogen only has one electron, right? So your hydrogen only have one electron, so it can't form double bond with carbon. So किसके बीच का bond होगा? Carbon carbon के बीच का, in between carbon carbon. So if your carbon and carbon has only single bond, that's called saturated hydrocarbon. If carbon carbon, all the carbon carbon bonds in a compound are single, okay, that's called saturated hydrocarbon. Okay, what about unsaturated hydrocarbons? So your unsaturated hydrocarbons are those hydrocarbons where either there is a carbon-carbon double bond or carbon-carbon triple bond. Either carbon-carbon double bond or carbon-carbon triple bond is there, okay? These are unsaturated hydrocarbon. Unsaturation is there. You can break these bonds. And add hydrogen because there is unsaturation. This is unsaturation. This is called unsaturation. Clear? Single bond saturated alkanes, double bond unsaturated. Correct, legend. Okay. Now, which is more reactive? Saturated hydrocarbons or unsaturated hydrocarbons? Which is more reactive? Tell me which is more reactive, saturated hydrocarbons or unsaturated hydrocarbons? Hi Anurag Kumar, I am good. How are you? So I am just waiting for your answer. Which is more reactive? Saturated hydrocarbon or unsaturated hydrocarbon? Which is more reactive? Yes, Lokesh. Tabish, your question has your answer. Hydrocarbons, they are able to dissolve in organic solvents because hydrocarbons are non-polar in nature, and your organic solvents are also non-polar in nature, and non-polar solvent can dissolve non-polar compounds. Unsaturated. Correct, legend. Unsaturated compounds are more reactive. Why are they more reactive? Because in your saturated compound, there is only one single bond. I don't know if you have heard of it or not. There is sigma bond and there is a pi bond. Yes, Tabish, unsaturated are more reactive because when you have carbon-carbon single bond, basically unsaturated hydrocarbon, this bond is very strong. This is your sigma bond. You have not heard of it, but I am telling you, when there is a carbon-carbon single bond there, when there is a carbon-carbon single bond there, or whenever there is a single bond, it is sigma bond. When there are double bond, one sigma and one pi. That means one sigma bond is there, one pi bond is there. If there are triple bonds, 3 bonds are there, then there will be one sigma and 2 pi bonds. 2 pi bonds, okay? And you don't know, but I'm just telling you, your sigma bonds are very strong than your pi bond because sigma bonds are formed by head-on overlapping and your pi bonds are formed by lateral overlapping. ये सब आप पढ़ेंगे in your next class, 11th standard, okay? So do not worry about these things. For now, only remember that we have single bond, which is very strong, okay? Single interaction is there, strongly bonded. When you have double bond, one bond is strong, one bond is weak, so you can break this bond. Similarly, when you have triple bond, one bond is strong, 2 bonds are weak, so you can break those 2 bonds easily, okay? That's why jitna easily, the more easily you can break something, the more reactive they will be, okay? presence of multiple bonds. Yes. Gia, ma'am, are you gonna start bio and physics code series? So it's already started, Gia. You can watch, you can go on the playlist section. It's already started. Okay. Legend, yes, correct. Rich electron density also. Electron density wala reason to basically the bond is weak. That's the only reason. That's why they are more reactive. Non-polar क्या है? So Ashish Ranjan, non-polar means when there are no charges, no poles, no positive negative pole. So if you have two atoms which have same electronegativity and they combine to form a bond, the bond formed is polar, non-polar bond. Okay. So if you have, let's say, hydrogen and hydrogen, both have same electronegativity. Okay. No one is getting positive, no one is getting negative. So this is a non-polar compound. There are no poles. If you have, let's say, H and Cl, so here your H has a slight positive charge. Why? Because chlorine is highly electronegative. Highly electronegative. There are poles, positive pole and a negative pole. That's why it's a polar compound. It's a polar compound. Unsaturated H2SO4 T. Hi Lakshita. H2SO4 loves water because both are ionic compounds. Both are polar compounds. Okay. H2SO4 ionic hai. Water also has poles. Polar compound. Aditya, important topics. You want the important topics? I'll take one more class for the important topics only. Don't worry. Abhay, Udan. Okay. Now, these are your unsaturated and saturated hydrocarbons, okay, which are more reactive. Unsaturated hydrocarbons are more reactive. Now, we discuss alkanes. What are alkanes? Alkanes have carbon-carbon single bond. What is the general formula of alkanes? CnH2n plus 2. CnH2n plus 2. Do not need to cram it actually. You can just memorize one compound, alkane alcoholic. Maybe you can start with CH4. Single bond, okay? See, one carbon can form 4 bonds, right? Only 4 bonds it can form, right? What if I replace this one hydrogen with carbon? Now this carbon can form 4 bonds, right? And one bond is fulfilled by this carbon, right? Now you can calculate it. 2 carbons I have, and how many hydrogens? 1, 2, 3, 4, 5, 6. So C2H6. That means I need 2 times plus 2, right? If I have 2 carbons, I need kitne hydrogens? 2 times. 2 times means 2 times 2 means 4 plus 2. If we are talking about alkanes. H2N, that's not the okay. So you can see if we have 2 carbons, we need 6 hydrogens. That means 2 times 2 twice plus 2. That's how you got your general formula. That's how you got your general formula, CnH2n plus 2. For alkanes, the general formula is CnH2n plus 2. Now there is one more kind of alkanes, cycloalkanes. They are alkanes, they are saturated hydrocarbons only. That means they have only carbon-carbon single bonds, but they are present in the form of a ring. They are present in the form of a ring. All the carbons are connected by a ring, okay? And they all are singly bonded. They all have single bonds, okay? Okay, what is the general formula? In one of my classes, one student asked me about the general formula of cycloalkane. So the general formula is little different. It is CnH2n. As you can see, it is similar to alkenes. It is similar to alkenes, right? But There is no unsaturation. There is no unsaturation in cycloalkanes. They are present in a ring form and all the bonds are saturated. All the bonds are single. Okay? That is your cycloalkanes. The example is hexane, C6H6. Sorry. Yeah. C6H12. Clear? Cyclohexane, cyclopentane, cyclohexane, okay. Degrade. Increase, you mean? So okay, moving on. It is not decrease. Physical state of alkanes change from gas to liquid as the number of carbon atoms decrease. Oh, you guys have pre-board from 15th Jan. You have 3 pre-boards. So your pre-board is starting from 15th Jan. Okay, so what's her name? Tabish. Tabish, what happens is when the molecular mass of your alkanes increases, so when you're going from methane to ethane to propane to butane, what is exactly happening is the intermolecular forces are also increasing. Okay, so gases to liquid to जैसे जैसे intermolecular forces increase होंगी, so you know the states, right? Gases has the weakest intermolecular forces. Then liquids has the intermediary intermolecular forces, and solids have the strongest intermolecular forces. Okay, so when the molecular mass increases, so when you're going from methane to ethane to propane, what is happening? Molecular mass is increasing, right? And due to the increase in molecular mass, the intermolecular forces are also increasing. Okay, so that's why from gases to liquids to solids. And the reverse reason you are asking, so obviously when the molecular mass is decreasing, so what is happening? When your molecular mass is decreasing, your intermolecular forces are decreasing. और सबसे कम intermolecular forces किस में होता है? Gases में होता है. Correct? I hope it clears your doubt. Now, alkenes. What are alkenes? Alkenes have one double bond. They have at least one double bond. They are called alkenes. What is the general formula of alkenes? The general formula is CnH2n. The general formula is CnH2n. Okay, why? Because that one bond जो additional hydrogen के साथ होता, that one bond is replaced by the carbon-carbon double bond. That bond is replaced by carbon-carbon double bond. Okay, so that's why the general formula CnH2n. Okay, the question comes from this are mostly assertion and reasoning type that we will discuss. So assertion and reasoning mein they will give you the general formula. They'll give you like you have C2H4, C3H6. Are they unsaturated or saturated? So you need to know the general formulas, whether they are alkanes, whether they are alkenes, or whether they are alkynes. You need to remember the formula. For alkanes, repeat with me, it's yes. For alkenes, it's CnH2n. For alkanes, it's CnH2n plus 2. For alkynes, it's CnH2n minus 2. H2n minus 2. Because there is one additional bond between carbon and carbon. There is one additional bond between carbon and carbon. Good. Actually, you should not... you should delete them because it's a very major distraction for you. And yes, so everyone who deactivated it, that's very good thing. Moving on, alkynes, at least one triple bond. Alkynes have at least one triple bond. Okay, they can be more than one also, but when the compound has one triple bond, hydrocarbon, when a hydrocarbon has one triple bond, that's called alkyne. Okay, yes. So if you have any problem remembering which is which, single किस में है, double bond किस में है, third triple किस में है, so simple trick is you can just write them. So you can just write them, okay? Alkane, alkene, alkyne, and focus on this word A, E, Y. Rest all the words are same, right? Only A, E, Y. And in your alphabets also, when you studying, okay, hold on a second. Why do alkenes prefer addition reaction while alkanes only do substitution? Tabish, that's the reason I was explaining. Your alkanes are saturated hydrocarbons. Your alkanes are saturated hydrocarbons. Already 4 bonds are fulfilled. There is no unsaturation. कोई है ही नहीं डबल बॉन्ड कि उसको तोड़ के you can make a single bond. है possibility. There is only one possibility. You can substitute the hydrogens or carbons. You can substitute them. You cannot add anything as already there is enough addition. सारे bonds are fulfilled, right? So what is happening here? You are not adding anything. कुछ भी आएगा, any atom will come. It will just substitute it. टक्कर मार देगा दूसरे hydrogen को and it will take its place. It's like that. Okay? Okay, while alkenes, for your alkenes, there is addition. Addition means this bond can break and you can add additional compound, additional atoms, okay? That's your alkenes. For your alkenes and also for your alkynes, addition reaction is possible. While for your alkanes, as they are already saturated, all the bonds are fulfilled, one thing can be done, you can kick out one atom and the other atom will come take its place, okay? For the alkenes and alkynes, you can add additional atoms. There is possibility because this bond can be broken. This bond, you can break this bond. We can break this bond. Clear? Okay, so alkanes, alkenes, alkynes are done. Moving on. Homologous series. Homologous series. What is a homologous series? Hello yoga con. Hello Olivia. I am Tabish left class. What is a homologous series? The questions will be different, Jia. This time they are introducing the competency based questions. Okay, so you need to focus on them also. So basically the direct questions won't come, they will ask question about the application. Major focus will be on the application part. Okay, so yes, if you are prepared, if you have your concepts correctly gathered, you know, if everything is revised and you know you remember your concepts, so there will be no issue for you. The pattern will be different from this section, from this session. Oh, no, I don't actually. Hi, Sarita. Yes, user, your name is so long. Same function group but different structure. Okay, so your homologous series are series of organic compounds having same functional group, same general formula, same functional group and same general formula, where each successive member differ by a CH2 unit. Okay, now if they have the same functional group, same general formula, that means they have same chemical properties also. They have same chemical properties. What about physical properties? So for physical properties, they show a gradual change. What does gradual change means? Either the properties will increase or the properties will decrease. Physical properties क्या होती है? Melting point, boiling point, solubility, right? So these properties will either increase or decrease when you are going down the series. Okay. Polymerization group but same functional group but different structure. Yes, same functional group, not different structure. So for homologous series, the structure is same functional group, same general formula. They differ only by the successive member. They differ by the CH2 unit. Okay, successive members differ by CH2 unit. Chemical properties be same hai. Yes, and CH2 unit means 14U. Okay. What is your doubt about polymerization, Sarita? Tell me your doubt about polymerization. What do you want to ask about polymerization? It's not in your syllabus, but I'll answer it. No worries. Okay. Yes, user. So, what is your name, user? What are you asking, Yoga? Okay, so your homologous series, it is a series of that have the same functional group, same general formula, same chemical properties, but gradual change in physical properties, and the consecutive members, successive members differ by a CH2 unit. Okay, for example, you have halo series, then you have alcohol series, right, where the functional group is alcohol. If the functional group is aldehyde, then it's a one homologous series. Ketone, one other homologous series. Carboxylic acid also has one other homologous series. Similar, you have alkane, where also homologous series, and alkyne, they also form homologous series. Okay. What is so Sarita, polymerization means addition, and addition reactions are not performed by alkanes because they are saturated. They already have 4 bonds formed. There is no unsaturation in them. So polymerization reaction alkanes show नहीं करेंगे. Okay, only shown by alkenes and alkynes. Okay, majorly alkenes actually. So many doubts you have. Okay, what is substitution reaction? Substitution, नाम में ही है, substitute कर रहा है. There is already a one compound, one atom here. Other atom will come and kick it out and take its place. Okay, substitution. So it is majorly shown by your alkanes. Okay, because they already have their 4 bonds fulfilled. There is no unsaturation. So what they'll do? Any atom will come and replace the other atom. Substitute, take its place. Take its place. Okay, and remove that atom. Okay, that's substitution. Hold on a second. Why we need classify like these? So Razia, we need to classify them because you have so many functional group. You are in 10th standard. You only have limited. These are the functional groups you have. Okay, but in your upcoming class, if you are studying science and like taking physics, chemistry, biology in next year also 11th standard, so you need, there is a need because you have whole one chapter dedicated to this. Okay, so you need to identify the different type of functional group, different type of homologous series. Okay, abhi to 4 5 are there only. ज़्यादा कितना है? 1 2 3 4 5 6 are there. 3 4 5 6 7 8 are there. Okay, then you'll have 20 30 something. Okay, so for that purpose you need the classification, so that you do not need to study each alag se compound. Okay, you can just do, yes, it comes in the alcohol, so I'll study it in alcohol. This group comes in the aldehyde, so I'll study it in the aldehyde chapter. Why alcohol and carboxylic acid series start with a single carbon? Why can alcohol and carboxylic acid series start with a single carbon? Yes, so single carbon से start होता है because the type of bonds they have for alcohol, the functional group is OH. It adds in the, like it is added at the end. So in before that, if you have one carbon, you can complete the valency of the carbon. So for example, you have alkenes or alkynes, right? So for alkenes and alkynes, the condition is the carbon-carbon should have a double bond. Carbon-carbon should have a double bond. That means 2 carbon are required. For these ones, there is no such. For this one, it is your aldehyde should come in between. No, sorry, there is oxygen and 1 hydrogen. Okay, this condition is there. It adds like this only. Your ketone, it comes in between. So that means your ketone ke liye you need either 1 hydrogen, 1 hydrogen. No, you actually need 2 carbon and 2 carbon. Then you have carboxylic acid. It also gets in the end. Okay, can add 1 hydrogen. Okay, that depends on what kind of functional group you are dealing with and what is the minimum requirement. Gia, I'll tell you my resolution by the end. Okay, I have made some resolution. I'll try to follow through them. Okay. Jai Shri Ram. Yeah, Jai Shri Ram. मैं ICSE student to class 10 है CBSE. So Avinash, you are ICSE, okay? No worries. This is, you are ICSE or CBSE. I'm very confused by reading your comment. Hydrogenation is addition of hydrogen. Addition of hydrogen is hydrogenation. Yes, ABCD. What was it out? Yeah. It's not according to me. Just addition of one CH2 group increase the intermolecular attraction. I'm not clear in that one. Okay. Tabish, right? So, okay, think it in a, if you have, let's say I have this bottle, okay? If I have this bottle, it's roughly 250 ml, I believe, 300 ml, let's say, okay? Just listen to it. If it is 300 ml, okay, what I can do, I can throw it, I can kick it, I can break it even with my hands if I put enough effort in it, okay? I can do that, right? But what happens if I increase the weight, molecular weight I'm asking? If I add too much water, इसमें कितना है अभी मुश्किल से 200 ml water होगा. Let's say if I somehow have a bottle that has 1000 liter of water, 1,000 liters of water. Will I be able to, kick it, break it, and, throw it? I can't, right? So when your molecular weight increases, the intermolecular forces also increases, right? The weight itna zyada ho gaya, you can't throw it, you can't kick it, you can't break it, right? You can't break it. Similar to that, agar intermolecular weight, if your molecular weight increased so much, जो किस केस में होता है, if you are increasing your molecular weight from going from your methane to ethane, propane, weight increase हो रहा है ना, your weight is increasing, molecular weight is increasing, and if your molecular weight is increasing, it will be very tough to break those bonds. Tough to break those bonds means intermolecular forces are increasing, and when your intermolecular forces are increasing, that means it's turning into solid. So gases to liquid to solid. I hope that clears your doubt, Tabish. Hello Naman. Hold on, कहाँ गए? Halogens are your group 17 atoms. These are your halogens. Fluorine, chlorine, bromine. These are halogens. Okay? Halogens needs only one electron to complete their octet. They are halogens. Avinash, ICSE, so no worries. For CBSE, this one is for CBSE only, but I believe there are topics that are similar to this one in your ICSE also. So if you find that helpful, please do watch it. First done. Halogen and functional group. Halogen is a functional group, Razia. Functional groups are a group of atoms. Functional group is a group of atom that gives a characteristic reactions. Okay. So for example, in alcohol you have OH. This is your functional group. Okay. One oxygen and hydrogen, they combine to form OH, and this functional group, this is called your OH, alcohol functional group. Okay. So halogen are similarly a functional group. Functional group is a different thing. Functional group have similar chemical properties. They are formed by combination of certain atoms, okay, that show characteristic chemical properties. Okay. जो रिएक्शंस अल्कोहल शो करेगा वो एल्डिहाइड शो नहीं करेगा, जो रिएक्शंस एल्डिहाइड शो करेगा वो कीटोन शो नहीं करेगा. इट्स लाइक दैट ओनली. ओके. So your halogens are also a type of functional group. When they get added to a compound, so they change the chemical properties of that compound, chemical plus physical properties. That is what a functional group does. Okay. And what are your functional groups? Alcohol, aldehyde, ketones, carboxylic acid, halogens. These are all your functional groups. Fifteenth of Jan. Hello Naman. Tejas, what are you asking? That's physics and chemistry you're combining. Yes Naman, what are your two questions? Yes please. Hello Arav. Naman, what was your question? Okay, Rizia. So, Tejas, phonons are in your physics. The packets of energy, quantum physics. What are you asking here? There is nothing of relevance here, okay? Go ask physics ma'am that question. Okay. So, yes. Okay, moving on. Now, how do you do the nomenclature for hydrocarbons? For different functional groups, okay? Okay, so nomenclature. Yes, sure. If that question comes in your exam, they just do answer it. Okay. Very smart, huh? Now answer these questions, okay? Just listen here. How do you do the nomenclature? So the basic one is you identify a parent chain. What is the parent chain? The parent chain is the longest carbon chain. Longest chain of carbon compounds, okay? Okay. Identify the parent chain. What is the parent chain? It is the longest chain of carbon atoms, okay? So for example, if you have so for example, if you have okay, hold on a second. Okay, so when you are doing the nomenclature, when a compound is given, in CBSE they don't ask much, बहुत difficult nomenclature they don't ask, they just ask the basic ones, okay? So firstly, what you do, you identify the parent chain. What is the parent chain? It is the longest carbon chain. Longest carbon chain containing the functional group, okay? It can be the longest carbon chain and it can still does not contain the functional group. So longest carbon chain containing the functional group. Okay. Okay, that's first thing. So if you are trying to write the name of any organic compound, so what you will do, you will identify the longest carbon chain and you name that as the parent chain. So here I will calculate it. 1, 2, 3, 4, 5. एक chain तो सीधा है. 1, 2, 3, 4, 5. 5 carbons are there. What if I just shifted this side? 1, 2, 3, 4, 3 and this side 1, 4. There is one carbon niche also, right? So only 4. So one is 4 carbon chain, the other is 5 carbon chain. Which should be your parent chain? Which should be your parent chain? Parent chain will be your 5 carbon chain because that is the longest carbon chain. So the parent chain is your 5 carbon chain. This is your parent chain. This is your parent chain. Okay. Now determine the functional group and suffix. So whatever be your functional group is, it will have a suffix. Suffix means it is added at the end. Prefix mean added at the beginning. Suffix mean added at the end. Okay. If a molecule has a long straight chain but a shorter chain, long straight chain but a shorter chain containing a double bond. So you will always prioritize the functional group. There is a priority series. There is a priority series where all the different functional groups are arranged. Okay. So for now, alkanes, in between alkanes, alkynes and alkanes, alkanes, alkynes and alkanes, alkenes and alkynes. Sorry. This is called the priority series. Hello Kaushal. Okay. So if you have two functional groups, alkanes and alkenes, so you can just remember the priority series, which is alkenes come before alkanes. So alkenes are given more priority, okay? Alkenes are given more priority than alkanes, okay? Do not worry, इतना difficult तुमसे नहीं पूछेंगे, trust me. 10th standard में they don't ask this much difficult of names. Next year you will need that, and in the beginning only they will give you that chart. They will give you that series, okay, where if more than one functional group is present, so which group is given more priority. For now, if a chain has a functional group, give that a priority, and functional group comes as a suffix, okay. If you have any substituent are those which are not considered as the functional group. They are taken as prefix. Okay. Now what do you do actually? So how do you write a name? You have a prefix, which is your substituent. This is your substituent. Then you have a root. Root means parent chain. How long a parent chain you have? If it has 3 carbons, it's prop. 5 carbon, it's pent. 7 carbon, it's hept. So that is the root, which is the name of your parent chain. Root name of parent chain. And in the end, you add the suffix for the functional group present. Suffix for the functional group present. Okay, suffix is the functional group, name of the functional group present. Okay, I will discuss the functional group we have. Okay, here. Now listen carefully. The suffix I am discussing here. So if your functional group is halogen. If your functional group is halogen, so what is the suffix or prefix you are using? Just tell me the suffix or prefix we are using. We will use a prefix. We will use a prefix. In this case, there is a prefix. And what is that prefix? It is halo. Halo means chloro hai to chloro, bromo hai to bromo. Okay. Okay. Alcohol has a suffix. What is the suffix? So at the end you have the parent name plus ol. Ol is the suffix you use for alcohol. For aldehyde, parent name plus al. Parent name plus al. Yes, legend, you study, do not worry. I am focused on you. I see you are the only one who's studying here. Okay, Tabish, I'll answer your doubt in a minute. Okay. Okay, ketone. For ketone, the nomenclature is parent chain, parent name plus on. And for carboxylic acid, again the parent chain name plus oic acid. These are the only ones that gonna ask that you need for your exam. Okay, we'll try to do 1-2 questions of it. Okay, we'll try it. Okay, just I need you guys to answer it. Okay, I need you guys to answer the name first, then I'll correct you. Okay, 2 questions we'll be doing about your nomenclature. Okay, so that any doubt you have, it'll clear. Okay. Okay, no hints also, na? I have removed it. Yes, correct. Just tell me the name of okay, you have on your screens, just tell me the answer of, tell me the name of this one. Legend, I am waiting for your answer. Tabish, what is the answer? What is the name of this compound? Tell me the name of this compound. Methyl pentane. Hi Honey Gupta. Hexane. So Kevin answered hexane. 3-methyl pentane. Legend also answered 3-methyl pentane. Jia, can you answer the question please? Aryan, can you answer the question? Yes, Legend answered 3-methyl pentane. Pentane. Sameer answered pentane. Okay. So we'll start by identifying the longest carbon chain. Longest carbon chain. So count it 1, 2, 3, 4, 5. If we go that way, 1, 2, 3, and this will be 4. So among your between your 4 and 5, which will be your longest carbon chain? 5, 1, right? So that means it is your parent chain. This is your parent chain. In this parent chain, we have a substituent. In this parent chain, we have a substituent which is at 3. What is that substituent? When your alkane is as a substituent, when alkane has one less hydrogen and it is added as a substituent, it is called alkyl, which here we have methyl. So 3-methyl pentane. Yes, 3-methyl pentane. Done. Okay, answer the next one. इसका नाम बताओ. What is the name of this compound? Correct. Legend answer was correct. Tabish का answer correct था. Then you have prime Cirox. So prime Cirox, your spelling was wrong, but your answer was, I believe it was 3-methyl pentane only. Kevin, it is ethanol. Legend answer it propanol. Again, no worries Kevin, take your time. Answer it first. So Tabish answered propanoic acid. Legend also answered propanoic acid. No, 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 no. You again, Sami, that's not ethanol. Okay, so yes, the correct answer is propanoic acid. Propanoic acid. 1, 2, 3 carbons are there, and 3 carbon means propane, okay? Propane, and oic acid is the suffix we use for carboxylic acid, okay? Propanoic acid. Akshi also answered correctly. Done. So Legend is correct, Tabish was correct, and Legend, Tabish, or कौन है? Akshi was also correct. Yes. Okay. Moving on. We have a lot to cover actually. Okay. What are the chemical properties of carbon compounds? So majorly they show four reactions, four type of reactions. First one is combustion. What is combustion? Combustion means addition of oxygen. If you add oxygen, we get carbon dioxide, heat and light. If we add oxygen to carbon compounds, we get carbon dioxide, heat and light. Okay, that is your combustion reaction. If you combustion means addition of oxygen, and when you add oxygen, you get carbon dioxide, heat and light. So if you have methane, if you add oxygen to methane, we get carbon dioxide plus heat and light, and you can see there is hydrogen also. Methane mein hydrogen is also there, na? So the hydrogen will convert into water. Okay, that's how you predict the products. So if you have oxygen plus any carbon compound, any hydrocarbon you have, alkane, alkyne jo bhi hai, okay? So if you add oxygen, you get carbon dioxide plus water, carbon dioxide plus heat plus light. That's combustion. Combustion means jalna. Okay? Okay. So combustion means normally there are two type of flames you get. Normally there are two type of flames you get. You get blue flame, blue clean flame, or you get a sooty flame. Sooty flame. Yellow sooty flame. So what happens is when you burn a saturated hydrocarbon, we get a blue flame. When you burn a saturated hydrocarbon in sufficient oxygen, it gives blue flame. Okay? Saturated hydrocarbon, sufficient oxygen supply. Then you get a blue flame. Okay, it's a clean flame. Okay, that means there is no pollution. All your hydrocarbon is getting converted into carbon dioxide plus water plus heat plus light. Carbon dioxide gas hai, right? Water, we have water, right? So there is nothing polluting. Carbon dioxide is a pollutant though. Hi Daksh. Yes, only in sufficient oxygen. When you have limited oxygen supply, दो केसेस होते हैं. You have limited oxygen supply or you have an unsaturated hydrocarbon. If you have an unsaturated hydrocarbon and you're trying to burn your saturated hydrocarbon in limited oxygen supply, in both these cases we get yellow sooty flame. So first case is burning unsaturated hydrocarbon. Unsaturated hydrocarbon. And the second case is burning saturated hydrocarbon in limited oxygen supply. Saturated hydrocarbon in limited O2 supply. Yes, complete combustion. Okay. When you have incomplete combustion of saturated hydrocarbons or your combustion of unsaturated hydrocarbon, incomplete combustion of saturated hydrocarbons or combustion of unsaturated hydrocarbon, both these cases will give yellow sooty flame. Second reaction that is shown by carbon compounds is oxidation. What is oxidation? Isn't it similar to we are adding oxygen? Combustion maybe we are adding oxygen. Similar hai, right? Then what is the difference? So in oxidation you are adding oxygen in a controlled way. In a controlled way, okay? Adding oxygen in a controlled way. So if you are adding oxygen in a controlled way, you may or may not get heat or light. In here, you're providing oxygen to do the combustion. You know, you need heat and light. Combustion में oxygen का addition जब भी होगा, every time you get heat and light. In oxidation, you may get heat or light, or you may not get heat or light because you're adding oxygen in a controlled way. So for example, if I have ethanol, this is ethanol, CH3CH2OH. Ethanol means the functional group is alcohol. Okay? Yes, Daksh. Gain of oxygen, loss of hydrogen. Yes, that is oxidation. Gain of oxygen and loss of hydrogen. So now see, we have this catalyst here. What do you call that? The catalyst, that is, this catalyst is helping do the oxidation, addition of oxygen. So is it in, what do you call it? Oxidizing agent or reducing agent? What do you call it? Oxidizing agent or reducing agent? Ethanol has a alcohol, OH, okay? And when you oxidize alcohol, so basic structure is this. This is ethanol, okay? And ethanoic acid is this. Arey. Hold on a second. Reducing agent. Arey, Daksh, reducing agent. Yes, Kevin, ask me a doubt. Oxidizing agent. Used for releasing rockets. Why does alkaline KMnO4 oxidize ethanol all the way to ethanoic acid? Because alkaline KMnO4 is a strong oxidizing agent. It is a strong oxidizing agent. नहीं तो alcohol से पहले बनता aldehyde या ketone and then it would have gone to carboxylic acid. But your alkaline KMnO4 is a strong oxidizing agent. That's why your reaction is getting carried out up to carboxylic acid. Yes, correct. It's an oxidizing agent. Yes, this is an oxidizing agent because it is supplying oxygen. It is supplying oxygen to ethanol. See, this is ethanol, CH3CH2OH. So you have one more in, this is ethanoic acid. In ethanoic acid, you have one more oxygen. There is addition of oxygen. Addition of oxygen means oxidation happening. Addition of oxygen means oxidation happening. And who is doing the oxidation? This alkaline KMnO4 or acidified K2Cr2O7. These are your oxidizing agents. What do you call them? Oxidizing agents, because they are supplying the oxygen. I hope it is clear. Oxidizes and should call a reducing agent. No, Akshi, if it oxidizes, it is called an oxidizing agent. An oxidizing agent oxidizes others and reduces itself. A reducing agent reduces others and oxidizes itself, okay? So if it oxidizes others, this alkaline KMnO4 or acidified K2Cr2O7, this oxidizes others, that means it's an oxidizing agent, okay? I hope it clears your doubt, Akshi. Why? Yes. Kevin, your answer is combustion. Oxidizes. Answer is combustion reaction. So when you have combustion reaction, lots of heat and energy is released. Okay. Okay. The next is addition reaction. Addition reactions are shown by your unsaturated hydrocarbons. You see, they have unsaturation. They have unsaturation. We can break this bond. This bond can be broken. If this bond is broken, so they need kitne? 2 electrons, right? So 2 bond will be formed. Okay. So H2 is added. H2, hydrogenation. This reaction is also called addition reaction of hydrocarbons, or you can call it hydrogenation. Hydrogenation means addition of hydrogen. Hydrogenation. Oxidation means addition of oxygen. Hydrogenation means addition of hydrogen. Okay. The saturated and unsaturated, it is a basic difference. Saturated means only single bonds. When an hydrocarbon has only carbon-carbon single bonds, it's saturated hydrocarbon. If a hydrocarbon has carbon-carbon double or triple bonds, it's called an unsaturated hydrocarbon. Okay? Okay, done. Addition reaction. So these are shown by your unsaturated hydrocarbons. What do they do? If we break this bond, that means two atoms can be added, and we are adding hydrogen. So one hydrogen atom will be added to each of the carbons. So one here and one here. So you have CH3, right? And there is a single bond. So your unsaturation, this reaction is very important. It is used to make your unsaturated compound into saturated compound. One more major application of this reaction is conversion of vegetable oil into vegetable fat. Saturated, yes. Daksh, I hope your doubt is clear. So this is one of the major reaction that is used to convert vegetable oil into vegetable fat. What is vegetable oil? Vegetable oil are unsaturated compounds. They are unsaturated compounds. उनमें unsaturation होता है vegetable oils में. Olive oil, flaxseed oil, sunflower oil, these all are your unsaturated compounds. Okay. So when you add hydrogen in presence of a catalyst, nickel, platinum, palladium, whichever catalyst you use. Catalyst का काम क्या होता है? What is catalyst? So catalyst is a substance that is added to a reaction to increase the rate of reaction. Okay, that's a catalyst. It does not get consumed in the reaction. The purpose of a catalyst is to increase the rate of a reaction. Simple. Now what happens here, that it will increase the rate. It will increase the rate of addition of hydrogen to vegetable oil. Okay, because there is vegetable oil means unsaturated compound. Addition of hydrogen will convert into vegetable fat, which is a saturated compound. That was your addition reaction. Done. Last one reaction is substitution. This is shown by saturated hydrocarbons. When one atom comes and replaces or take place of the already present atom in a compound. Okay, so क्या करा? Already we had hydrogens. Chlorine came. It kicked out the one hydrogen and took its place. We got CH3Cl. Okay, the reaction happens in sunlight, in presence of sunlight. It's very slow reaction. Slowly होता है. Okay. Yes, Tabish, the product is more stable because you are getting a saturated compound, and your saturated compounds are more stable than your unsaturated compound. As I've discussed, unsaturated compound are more reactive than your saturated compound, and because of that reason, because unsaturation say we are getting converted into saturated. Okay, so because of that reason the stability increases. Okay, that's why the product of addition reaction is more stable, because the product is saturated. We are getting unsaturated reactant to convert into saturated product. Okay, moving on. Ethanol and ethanoic acid. You already know the answer. It's like in your question you have the answer, Tabish. Yes, legend. Good. Okay, ethanol versus ethanoic acid. Ethanol versus ethanoic acid. Ethanol versus ethanoic acid. How do you synthesize ethanoic acid? Oxidation of ethanol gives ethanoic acid. Oxidation of ethanol gives ethanoic acid. The functional group is OH, ROH. This is your alkyl group R, and this is OH. And in case of ethanoic acid, the functional group is COOH. RCOOH. Clear? Ethanol is colorless liquid. It is soluble in water. It is colorless, it is soluble in water. It has a really nice smell. Okay, this is your daru. This is daru. Okay, how do you prepare it? By fermentation, or basically you oxidize. If you oxidize an ethane, your oxidation of ethane also gives ethanol. Okay, now where do you see ethanoic acid? Ethanoic acid, if you take 5-8% solution of ethanoic acid, 5 to 8% ethanoic acid in water, you get vinegar that you use in everyday life. In our homes also we use it for making pickles, for making something Chinese. Okay, that's why you use vinegar. Vinegar is made up of ethanoic acid. The common name of ethanoic acid, is carbonate, test, litmus paper, behavior. Yes, acid है ना. So common name of ethanoic acid is acetic acid. Acetic acid. Okay. The reactions we'll discuss later, detail में. Okay. Then you have soaps and detergents. What are soaps? What are detergents? Before that, I want to discuss with you the reactions actually. The chemical properties of ethanol. What reactions are shown by ethanol? Then we'll discuss soaps and detergents. Yes, ethanol and ethanoic acid have different, they have lots of differences. The first one in reactions mein dekho. So when you do combustion of ethanol, the product formed is carbon dioxide, water, heat and light. If you do combustion of ethanol, the product is carbon dioxide, water, heat and light. Okay, so carbon dioxide, see, we have oxygen, this is ethanol. What will be the product? When you combust a hydrocarbon, you get carbon dioxide. So a carbon dioxide we removed. Ab bacha kya? There is hydrogen also. There is oxygen. So it will form water molecule. And if it is a combustion, we know heat and light will be there. Heat and light will be there. So that is your combustion reaction. Second chemical property of ethanol is reaction with sodium metal. Reaction with sodium metal. Reaction with sodium metal. So when ethanol reacts with sodium, the product is sodium ethoxide. The product formed is sodium ethoxide plus hydrogen gas is evolved. Now hydrogen gas is evolved with a brisk effervescence. That means bubbles of hydrogen gas will come. So if you have a beaker that has ethanol, and if you add sodium to it, if you add sodium to it, it will form sodium ethoxide and bubbles will form. These bubbles will form. Bubbling effect because of the hydrogen gas, released. Because of the hydrogen gas released. So this is also a test to detect if ethanol is present or not. It is a test to detect if ethanol is present or not. Clear? Test for ethanol. Okay, next one is dehydration. Dehydration means, for example, right now I am dehydrated. I have like pani ki kami, that's dehydration. So that means removal of water. That's dehydration. Okay, removal of water. Removal of water is dehydration. I'm not dehydrated anymore. Okay, so what do? एक ethanol का molecule लो. I took one ethanol, right? So what do? If I just write CH2 here, add one hydrogen. Okay, so one hydrogen is removed from this one. OH is removed from this other carbon. From the left carbon you take one hydrogen, from the right carbon you take OH. Okay, that means one water molecule is formed. You remove that water molecule. क्या बचा उसके बाद? CH2, right? CH2. There will be a double bond. There will be double bond because they want to get stable also, right? Single bond में तो they won't satisfy their valency. So what they'll do? They'll form a double bond. Yes, rapid escape of gas in form of bubbles from a liquid. Yes, correct, legend. Okay, so we do this reaction in presence of hot concentrated sulfuric acid. Okay, so what do? So you take ethanol. Ethanol, so you remove one water molecule. How do you remove? From the one carbon you take one hydrogen. From the other carbon you take OH. Okay, one water molecule is removed. Bacha kya? CH2. This is ethene. Okay, yes. Moving on, there are some chemical properties of ethanoic acid also. Okay, the first one is, we had ethanol, right? So if you treat ethanol with ethanoic acid, we get an ester. Ester are these fruity smelling, बहुत sweet smelling, have this fruity smell. These are those compounds. Okay, the name is ethyl ethanoate. Now how are these formed? You have CH3COH, which is ethanoic acid, combined with alcohol, ethanol. So we are having, यहाँ से what will remove? One hydrogen from here will be removed. No, actually OCH2 CH3, yeah. So here one hydrogen is removed and from here OH is removed. So you have one water molecule that is removed and CH3CO OC2H5. Clear? Hi Rajveer. You joined very late, Rajveer. Renu Devi. ये chapter important, Renu. This chapter is important because you guys don't study it. Because you guys have some problems, I think. इसलिए लगता है. But it's not that hard. If you are following your Ekta Ma'am till now, it would have been very easy. Okay. So esterification means reaction of ethanoic acid with ethanol and we get an ester, formation of an ester. How is ester formed? So carboxylic acid जो है हमारा, which is ethanoic acid, OH group from the ethanoic acid and the hydrogen from the ethanol both gets eliminated as water molecule and you just add whatever part is left. What is left from here? CH3CO. From this side you have OC2H5. Clear? That's your ester. Now if you want to what are we doing? We are combining ethanol with ethanoic acid in acidic medium. So if I want to reverse this reaction, if I want my ethanol and ethanoic acid back, so what will I do? I'll add base. Instead of acid, I'll add base. So the reverse reaction of esterification is saponification. The reverse reaction is saponification. Okay, hold on a second. Hi Rajveer. Carbon soot क्या है? So carbon soot means sooty flame. So when you try to burn, when you have you ever tried, burning the LPG cylinder in your homes, right? It gives a blue flame. But when you try to burn some wood, firewood, if you collect from somewhere, and if you try to burn it, so it has that yellow colored flame, right? That yellow colored sooty flame. If you कोई भी बर्तन भी आप उसके ऊपर रखोगे, तो what will happen? It'll get this black covered soot. Soot means black covered, this black thing that will cover your vessels. Okay, that sooty flame. Incomplete combustion की वजह से जो होता है, it happens because of incomplete combustion. Namaste cat lover. Legend answered alcohol plus carboxylic acid form ester, right? And the reverse of esterification is saponification. That means if you just add base to an ester, you get carboxylic acid and alcohol. Clear? Saponification, sooty blue. No. Oh, cat lovers use. Okay. Yes, so legend, saponification is the reverse of esterification. So we are doing what? We are adding ethanol and ethanoic acid, right, in presence of an acid, and we are getting an ester. But if we reverse this reaction, so if an ester is treated with a base, we heat it, what do we get? We get acid. This is an acid, right? CH3CONa. If we replace the Na with hydrogen, this is an acid. And alcohol. Acid and alcohol. So acid plus carboxylic acid plus alcohol gives ester. Ester in presence of base will give carboxylic acid plus alcohol. It is the reverse of esterification, saponification. Basically, this is soap. Okay, soap formation. This is a reaction जहाँ से soap बनता है. Formation of soap happens. Okay, so ester को we treat with a base, then we get a soap. Your soap are bases, right? The thing that you shower with, that's a base. Okay, moving on. Now there are some tests for ethanoic acid also. One was litmus paper test, right? And if you want to differentiate between your ethanol and ethanoic acid, there are two tests. The litmus test was one, and the second was sodium metal test. Okay. Now for ethanoic acid, if you just want to test whether ethanoic acid is present or not, you have two tests. First one is sodium bicarbonate test. What is sodium bicarbonate test? So you treat ethanoic acid with sodium bicarbonate, we get sodium acetate, water plus carbon dioxide, and this carbon dioxide gas will give brisk effervescence. So this is a test for determining whether ethanoic acid is present or not. Okay. Second test is your esterification, which is your ester test. Ester means if you combine ethanol with ethanoic acid in presence of an acid, we get an ester. Remove क्या होता है? Remember it. From the CH3COH, this OH is removed, and from your alcohol, the hydrogen is removed. Okay, and that's how you get your ester. Ester are the sweet smelling substances. Okay, they are majorly used for making perfumes to form methane. Ethanoid से methane. Okay. Moving on. I think questions are here, but before that I want to discuss one thing, which is your soaps and detergents. Soaps and detergents. What are soaps? Soaps are sodium potassium salts of long chain fatty acids. Sodium or potassium salts of long chain fatty acid. What are detergents? They are ammonium or sulfonated salts of long chain carboxylic acid. Okay, I'm sorry, ये ज़्यादा ही कुछ ज़्यादा कलरफुल हो गया है, I believe. Yeah. So detergents are ammonium or sulfonated salts of carboxylic acid. Ammonium or sulfonated. Soaps are sodium or potassium salts of fatty acids or carboxylic acid, of long chain carboxylic acid. The basic difference is soaps does not work in hard water. What is hard water? Hard water is water that has calcium or magnesium salts. Water that has calcium or magnesium salts in it, that's hard water. And water that does not have calcium or magnesium salts in it, that's soft water. Okay? So, when your water is hard, soaps won't work in it. So, what will work in that? Detergents will work. What happens when what happens when there is hard water and you add soap to it? You try to wash it with soap. So what will happen? Scum formation will happen. What will happen? Scum formation will happen. What is scum? So scum may basically, your soaps are sodium potassium salts of carboxylic acid, right? Sodium or potassium salt of carboxylic acid. Hard water has magnesium and calcium salts. So what will do? Magnesium and calcium will replace sodium or potassium here, okay? And then this slimy thing will be formed. That's called your scum, okay? The water the cloth won't be clean. Nothing will be cleaned, okay? That's scum. Micelle is also there. What is micelle? It is the cleansing action of soaps or detergents. Both works in the same way. What happens is, for micelle, we are talking about micelle formation. So you have, this is your micelle. It has a hydrophilic head. Hydrophilic head and a hydrophobic tail. Hydrophilic head and a hydrophobic tail. Hydrophilic head means that this part is water loving. Philic means love. Philic means love. Okay. Sharma ji, I'll answer your doubt in a minute. Let me finish the micelle first. Okay. So head is hydrophilic. That means head is water loving. This micelle formation we are talking about. So we have this soap. Okay. So what is this? Soap has this hydrophilic head, the head that is water loving, and a hydrophobic tail. What is hydrophobic tail? That means this is water fearing. It does not like water, hates water. Hates or fears water. Okay. So that means when there is a dirt or grease particle, if it hates water, it will love the dirt or grease. Okay. So how it orients itself? This tail wala part, if we have a oil, or this is oil or grease maybe. So this tail will align itself in such a way around the dirt. Okay. This is the hydrophobic tail. I hope it is visible. If it's not, I'll use the other slide. Okay. So if you have, this is the oil or dirt. Okay. And around it, it will arrange itself in such a way This is the hydrophilic. Hydrophilic part is outside and the hydrophobic part is inside. Okay, this formation is called micelle formation. Micelle or micelle formation. This is your micelle. This structure is called micelle. Okay, now if you just scrub this part out, if you just try to put force, if you put force on it, try to scrub it out or wash it with excess of water, this impurity will wash away. Okay, because this formation has happened. Your oil or particle is surrounded by these soap molecules, these soap molecules that has a hydrophilic head and a hydrophobic tail. Okay. Okay, now Sharma ji ka doubt. See, graphite conduct electricity because of its structure. In graphite has a hexagonal 2D array structure in which each carbon atom is bonded to 3 other carbons. That means there is one free electron present, and due to that one free electron, it can conduct electricity. While diamond has a 3D structure in which each carbon atom is bonded to 4 other carbon atoms, there is no free electron present, and due to the absence of free electrons or ions, it does not conduct electricity. Hi Harshit, I hope it is clear. Sharma ji, I hope it is clear. Okay. Now let's try to solve some questions. Okay. Let's try to solve some questions. Legend, now your turn. You answer. One more difference was there. Soap is biodegradable. Detergents are non-biodegradable. Okay, so that's why it is not environment friendly to use detergents. Okay. A. Covalent compounds like methane and ethanol generally have low melting and boiling points. The intermolecular force of attraction between the molecules of covalent compounds are very weak. Yes. Answer the question, Legend. Akshi also answered A. Correct. Yes, so Legend also answered A. So anyone who answered A is correct, which is correct. Your covalent bond is very weak, and because of that reason your covalent compounds have low melting and boiling point. We discussed it right at the beginning of the class. Okay, next question. Harshit also answered A. Hi Ifra. An aqueous solution of ethene will decolorize bromine water, and ethene is an unsaturated hydrocarbon and readily undergoes an addition reaction with bromine. Okay, answer this one. There is a bromine water test. There is a bromine water test. I'll explain the bromine water test. So if you put bromine water in unsaturated compound, if you put bromine water in unsaturated compound, it will decolorize. What is the color of bromine water? It has this reddish brown color. And if you put bromine water in unsaturated compound, it will decolorize. But if you put bromine water in a saturated compound, it will retain its color. It will retain its color. I hope that answer your question. I hope that answered this question actually. Hold on a second. Hello Tushar. So legend answered D. Aqueous solution of ethene will decolorize bromine water. Hi Tushar. Akshi answered C. Hello Tushar. Okay. Okay. Answer the question, everyone. So one thing I told you that your unsaturated compound, they decolorize bromine water. They decolorize bromine water. Yes. So ethene is an unsaturated compound and readily undergoes addition reaction with bromine. Okay, cat lover. Okay, sure. So the correct answer is A. Both statements are correct. Yes, ethene will decolorize because ethene is unsaturated and your unsaturated compound decolorize bromine water. Second one is ethene is an unsaturated hydrocarbon and it will undergo addition reaction. Yes, it will undergo addition reaction with bromine because unsaturated hydrocarbons undergo addition reaction. Okay. Moving on to the next question. Butane 1-ol and butane 2-ol exhibit similar chemical properties. Butane 1-ol, butane 2-ol, दोनों क्या है? Alcohols है, right? So yes, they will exhibit similar chemical properties. Okay. Yes, legend, no worries. They belong to the same homologous series of alcohols and possess the same functional group OH. This is also very easy. This is also very easy. Hi, Lakshmi. Hello Tushar. Butane 1-ol, butane 2-ol exhibit similar chemical properties. That is correct because both are alcohols. They will show the similar chemical reactions. They belong to same homologous series. Yes, because they have same functional group, same general formula. Clear? And possess same functional group. Okay, that's correct. So both assertion and reasoning is correct. Okay, moving on. The complete combustion of hydrocarbons like methane produces carbon dioxide and water. The incomplete combustion of hydrocarbon in a limited supply of air can produce carbon monoxide. That is also yes. Legend, correct answer. Your answer was correct. Hi Ifra. A. Tushar, your answer is correct. Cat lover's answer is also correct. Lakshmi, can you answer it? Harshit answers is A. Cat lover's answer is B. Okay, answer it. Cat lover is also changing his answer. Okay, everyone, answer it. So cat lover, which is your answer? Okay, Tushar answered B, Legend answered A. C. The complete combustion of hydrocarbons like methane produces carbon dioxide and water. That is correct. We know that statement is correct. Incomplete combustion of hydrocarbons in a limited supply of air can produce carbon monoxide. That also is correct because we know complete combustion may we get carbon dioxide plus heat plus light. But if it is incomplete combustion, then we get carbon monoxide. That is correct. But one is talking about complete combustion, the other is talking about incomplete combustion. So both are correct, but your reason is not the correct explanation for assertion. Question कैसे होता है? Assertion में you given a statement and in the reason you given the reason. Why is that so? So does that explain why is that so? Does the second reason, this reason, explain why about the complete combustion? It does not, right? So question 4 का answer is Legend. Question 4 का answer is B. Harshit. B. Cat lover also answered B. No, cat lover is also, yeah. So don't do that, guys. Yes. So the correct answer is B. Okay. Moving on to the next question. Ethanoic acid is a carboxylic acid that shows several important chemical reactions. Write the balanced equation for the reaction of ethanoic acid with sodium metal, solution of sodium hydroxide, solid sodium carbonate, pure ethanoic acid called glacial acetic acid, common name for 5 to 8%, aqueous solution of ethanoic acid. Some questions we have answered already. Out of these, this one, ethanoic acid reaction with sodium metal, the product formed was CH3COO-Na. This was the product form, plus H2 gas was evolved. It was used as a test for ethanoic acid. Solution of sodium hydroxide. So CH3COH is an acid, right? And if you treat ethanoic acid with a base, you get salt, COO-Na plus H2O. Solid sodium carbonate, NaHCO3. What was the product? The product formed were sodium acetate plus carbon dioxide plus H2. Carbon dioxide plus H2. What is the common name for 5 to 8% solution of ethanoic? This is vinegar. Okay, why is pure ethanoic acid often called glacial acetic acid? Just tell me this one question's answer. B. Everyone tell me the answer of B. Just tell me the answer of B. It's a very phonetic reason. It is in solid form. No worries, Legend. Melting and boiling point is different. Actually, glacial acetic acid is called because solely of its appearance. Yes, so it has a freezing point of 16 degrees Celsius. Your acetic acid has a freezing point of 16 degrees Celsius. 16. At this temperature, when it freezes in like a glacial kind of glaciers, you know, na? Pointy glaciers. So it freezes in that shape only. That's why it's called glacial acetic acid. Yes. It forms like ice, glacial ice-like crystal, glacier-like clusters. Sorry, glacier-like crystals. Okay. Okay. Moving on to the next question. The unique nature of carbon atom allows it to form a vast number of compounds. State two characteristic properties that are responsible. What are covalent bonds? These questions are all very easy. I don't know why you put it here. Anyways, so the first one is, two characteristic properties are catenation and tetravalency. Catenation and tetravalency. What are covalent bonds? Bonds formed by sharing of electrons. By sharing of electrons. Explain why covalent bonds generally have low melting and boiling points. Because covalent bonds are weak. Because covalent bonds are weak and very little energy is required to break these bonds. Because covalent bonds are weak in nature. Are weak. Called glacial acetic acid because it freezes into ice like solid below 17 degrees Celsius. Correct answer, legend. Draw the electron dot structure for a molecule of carbon dioxide. Electron dot structure. CO2. This is the electron dot structure of CO2. Explain why carbon dioxide gas is effective in extinguishing most types of fire. Oxygen ka supply band, done. When you have no oxygen supply, the fire will itself extinguish, okay? So it cuts off the oxygen supply. Cuts off the oxygen supply. Next question. Alkanes are generally considered chemically unreactive or paraffins. Alkanes are saturated hydrocarbons containing only strong CC and CH single covalent bonds which are difficult to break. Correct answer is A. Okay, cat lover answered A. They are chemically unreactive. Yes. Unsaturated. Yes, alkanes are saturated, containing only so the correct answer is, how many questions are there in total? Actually, there are 15 questions in total. Legend answered A. Cat lover answered A. Hi Harshit again. Okay, done. So the correct answer is A. Yes, because alkanes are chemically unreactive and the other name you call them is paraffins. Okay, they are saturated hydrocarbons. Unsaturated are alkenes and alkynes. They contain only strong single CC bond and CH bond. Carbon-carbon and carbon-hydrogen ka single bond they contain, okay, which is difficult to break. Okay, moving on to the next question. All members of alkane homologous series are saturated hydrocarbons. They contain only carbon-carbon and carbon-hydrogen single covalent bonds. So your answer, legend, cat lover, your answer were correct. Your answer was correct, okay? This one is also self-explanatory. This answer is also very correct. Please, this question is also very easy. You can answer it. All members of alkane homologous series are saturated hydrocarbons. So all will be alkanes, right? Alkane homologous series means all will be alkanes. Alkanes are saturated hydrocarbons. Yes. Cat lover answered A. They contain only carbon-carbon and carbon-hydrogen single covalent bonds. Yes, because they have carbon-carbon and carbon-hydrogen single covalent bonds. Because of that, they are saturated hydrocarbons. So the reason does explain the reasoning. Because majorly the only assertion and reasoning type of question comes from this chapter. That's why I am preparing you for them. Yes, because the questions, simple questions बहुत कम आते हैं. Majorly they ask these kind of questions only. That's why I'm asking you these only. The correct answer is A. Next question. Ethanol is an important industrial compound. Okay, write a balanced equation for the complete combustion of ethanol. It's there, C2H5OH plus O2. I believe 3 here. Then you get CO2 plus H2O plus heat plus light. Okay, if you balance it, so you have 3, 2, 6, 7. Guys, balance it. Actually, I'm not gonna balance it, or I can though. No, Harshit, all answer is not A. Sulfuric acid, excess concentration 443 Kelvin. Name the reaction and write the chemical equation. When ethanol is treated with excess concentrated sulfuric acid at 443 Kelvin, what happens? Tell me guys, what happens? Dehydration happens. What happens? Dehydration happens. Okay, so this reaction is dehydration. Balance this reaction on your own. It's in the slides only. Okay, dehydration. What happens when ethanol is warmed with ethanoic acid in presence of a few drops of concentrated sulfuric acid? Ethanol is warmed in presence of ethanoic acid. We have esterification. Yes, correct, legend. Esterification. Cat lover answered ethene plus H2O. Correct. Dehydration में वही बनता है. Uses of ethanol, it is used as in medicines. It is used to make perfumes, and yeah, also used as a medicine also. Like medicine, we cough syrup and everything. Okay. Next question. Ethanoic acid acid reacts with sodium carbonate to produce carbon dioxide gas with brisk effervescence. That is correct. All organic compounds that contain a carboxyl functional group are acidic in nature. See, what is the answer of this one? C, esterification. Correct, legend. That was correct. Yes, alcohol used in wine, beers. Yes, for drinking purpose. Uses maybe I would say alcohol ka uses hoga will be for your perfumes and in medicines. That's uses. Consumption mein that's not a use. Answer this question. No, cat lover. A nahi hai iska answer. See, both statements are correct. Yes, ethanoic acid, if reacts with sodium carbonate, we get brisk effervescence, carbon dioxide gas with brisk effervescence. Similarly, all organic compound that has an COH functional group, they are acidic in nature. Both are true, but reason does not explain the assertion. So the correct answer is B. Not C, Daksh. Cough syrup, yes. Butene is an alkene. It can exist in the form of several structural isomers. कौन सी homologous series में butane belong करेगा? Which homologous series? It belongs in the alkene series. It belongs in the alkene homologous series. Okay? 3 structural isomers of butene. 3 structural isomers of butene. So we have, I'll draw it. One butene, then you have 2 butene, and then you have 3 structural isomers you need now. So we'll just shift one. Butene 1, but 1 in. Okay, done. These are the three structural isomers. If you do the IUPAC name, this is but1ene, but2ene. Hi Shweta. Okay, and this is 1, 2, 3, 2-methyl propene, 2-methyl propene. Okay, how do you convert but1ene to butane? So but1ene को क्या करेंगे हम? Simple hydrogenation. If we add hydrogen in presence of nickel or palladium, we get butane. We get butane. Okay, moving on. Next question. The organic compound propanone contains which of the following functional group? Legend, yes, everyone's aura is quite stable. Answer the 12th question. We have 3 more questions left. The organic compound propanone contains which of the following functional groups? Please answer it quickly. Yes, propanone has. Shweta answered D. Cat Lover answered B. Propanone. Legend answered D. Akshi answered D. Your Cat Lover answered D. Done. Okay, the correct answer is D. Propanone means ketone functional group. This is propanone. Ketone functional group. Moving on. Next question. Missile का structure बनाना है, help of missile structure. We already done this part. So this is your missile. We have oil, and around that this is your missile. This is missile. Okay, why are soaps not effective in cleansing agents in hard water? Because they form scum. They form scum. Done? Yes, done. Next question. Soaps are not effective cleansing agents in hard water. Soaps form insoluble scum, precipitate scum with the calcium and magnesium ions present in hard water. Yes, this one's answer is correct. I'm not going to wait for you guys' answer because मैंने अभी answer कर दिया. Correct answer is A. Last question. Last question. ये वाला you have to answer. Okay? Legend, Cat Lover, Shweta, who is there? Akshi, everyone, please answer this one. Okay? What is the IUPAC name? What is the IUPAC name of these compounds? This is the last question. Then we are done. Yes, Cat Lover, the answer was A. XYZ also answered A. Just tell me the IUPAC name of these compounds, okay? And then we are done. I hope you enjoyed the class. If you did, please give it a like, okay? It really means a lot. Give it a like, give it a thumbs up. Okay, my dear kids? Okay, just start answering these one by one. And do subscribe to the channel, okay? Bromoethane. Chalo, one by one start karo. First, second, third, sabka do. Okay, bromoethane. So we have 1, 2. Bromo. Root name is eth. And functional group is ane. Bromoethane. Done. Second one. What is the answer for second? What is the IUPAC name of second one? Which functional group is that? And this one. Okay, answer the second part. Second part. Metheon. Cat Lover, that's a very... Metheon. It's not metheon. Okay, it's an aldehyde. It's an aldehyde. Not eon. Nee, it's not eon. Eth. Legend, इसमें 2 कार्बन कहाँ है? It has only 1 कार्बन. Propyne. Propyne भी नहीं है ये. I'll draw the structure for you. Yes, Legend, correct. It's methanol. It's an aldehyde. That's why we use the suffix al. We use the suffix al. Okay, so it's methanol. Last one on your screens. Yes, bromoethane, methanol. Shweta answered correct. Okay, Legend answered the last one. 4-methyl pentuene. Okay, let's start. 1, 2, 3, 4, 5. On 4 we have a substituent. Yes, Legend is correct. So on the 4th we have a substituent, that is methyl. So that's 4-methyl. And the parent chain, this is the parent chain. The root is pent, because there are 5 carbons. So root is pent. And on the second position we have a double bond. On the second position we have a double bond. Correct, Legend, your answer is correct. This is the final answer. There is no propyne, cat lover. There is no propyne here. Okay. So everyone, that was it. If you have any doubts, drop them in the comment section. I'll answer them. And I hope you enjoyed the class. You learned about carbon, its compounds. I hope you do not fear this chapter anymore. That was it. And have a great day. Thank you for staying so long, Legend, and literally you stayed till the end. Thank you so much and take care. Bye bye. Do subscribe to the channel, and yeah, actually do give a thumbs up or like to this video if you enjoyed it. Okay, bye guys. Yes, almost 3 hours.